We're looking at section 7, using the commutative property, associative property, and distributive property to simplify expressions. And we're combining things together. Basically, we're shifting things around or putting them together is what we're looking at. We're looking at different ways to do that and still follow the rules, basically, for math. So a couple different properties. You've looked at these before. I know you have because I saw you make posters of them in 6th grade. You made posters for commutative property, you made posters for associative property and distributive property. So don't tell me you haven't seen these before. Now, you might have forgotten about them, but you've seen them. Commutative property. So commutative property works for adding and multiplying only. Adding and multiplying only. So you'll see those right here. Basically, it says that 2 plus 7 is the same as 7 plus 2. Now, I say adding and multiplying only because 2 minus 7, don't write this down, 2 minus 7 is not the same as 7 minus 2. Does not work for subtraction. 2 minus 7 is negative 5, 7 minus 2 is 5. However, for addition, the commutative property works great. It says that we can flip-flop those numbers and nothing really changes with the result. Same thing for multiplying. 3 times 9 is the same as 9 times 3. But don't try to use it for division. 3 divided by 9 is 1/3. However, 9 divided by 3 is 3. 1/3 and 3 are different. And so it does not work for division. It does not work for subtraction. But the commutative property is a nice tool to have for addition and multiplication. Associative property. When you associate with people, you hang out with them. Those are people you associate with. You like them, not necessarily, but at least you hang out with them. You spend time with them. So the associative property here says that for addition and multiplication, it works for both. That if we have 6 plus 8 plus 2, if we group 6 plus 8 together and we do that first and then add 2, it's the exact same thing as doing 8 plus 2 first and then adding 6. Now again, so that's our associative property. Same thing for multiplication. We've got 7 times 4 times 5, and it doesn't really matter if we do 7 times 4 first or 4 times 5 first. And that works for adding and multiplication. All right, so those are two properties. We'll spend a little more time talking about those in the next video. So I wanted to address them now, though. So mental math. This is where we can use some of that associative property to rearrange things and do it in our head. So 1/3 times 5 times 33 looks challenging because there's fractions and they're not nice and there's big numbers and small, lots of them. However, if we use the commutative property, it's all multiplication here, and we flip-flop 1/3 and 5. Let's do that. So 5 and 1/3 and 33. So write that down. So I flip-flop those. I use the commutative property. This is a little bit easier. 1/3 times 5 does not get us very far. 1/3 times 5 is 5/3, but that doesn't get us very far. If I look now at 1/3 times 33, 1/3 of 33, well, if I'm taking 1/3 of something, that's like dividing by 3, because that fraction bar here, that's just division. So that's divided by 3. 33 divided by 3, that's just 11. So 1/3 of 33 is 11. Times 5 is 55. So that's something we can do in our heads. You wouldn't normally show the work for this. For this problem, I am going to ask you to write it down just so you have examples of it. But this is a way to use the commutative property and associative property to do some mental math and try and work it out without outright showing all your work and showing all the steps involved and doing all that multiplication. So 1/3 times 33 is a lot easier to do in our heads than 1/3 times 5 times 33. Try using those properties to simplify this one. Pause it, try flip-flopping things around, seeing what you can do to make this an easier problem to work with. I'm assuming you paused it. Please do. If you haven't paused it yet, pause it. I am going to work through it. Now, again, you would normally do this mentally, and I get that. It says mental math at the top, but I'm still showing my work. One way that we can use these properties to help ourselves make things easier is to combine those thirds. We've got 1/3 and 2/3. That seems to work better together than this 4 in the middle. So let's use that commutative property, and let's flip-flop these two. So I'm going to instead write 4 plus 15 and 1/3 plus 1 and 2/3. Because if I do that, if I now look at 15 and 1/3 and 2 and 1 and 2/3 together, 1/3 plus 2/3 is 3/3. Whoa, right? So 1/3 plus 2/3 is 3/3. That's one whole. 3/3 is one whole unit. So I've got 15 and 1/3 plus 1 and 2/3. Now I told you that it doesn't always work to leave them as whole numbers and to add things together. But in this case, it does work for us. That 1/3 and 2/3 is one whole plus another one plus 15. So that's going to give me 17. 15 and 1/3 plus 1 and 2/3 is going to give me 17. You can check that doing it the long way and getting improper fractions. It does work out. 4 plus 17 then is going to be 21. Everybody's favorite. So that's how we can use these properties to do some mental math. One that's even more powerful that we're going to use all the time. This is a huge one, distributive property. This allows us to do so much. When you get to next year's math, the second half of this red algebra book, you are going to use distributive property so much it's going to hurt. You're going to love it. It's going to be great. So the distributive property allows us to distribute things. If I have money, I don't know why, but I always go back to money. If I have money and I want to give it to all the students, I need to distribute that money. So I'm going to distribute it around to everybody. And that's basically what we're doing here. We have this 3, and there's a 4 and an 8. So those are the students right there, student, student, teacher. We'll go with teacher. There we go, teacher. The teacher is going to distribute to the 4 and to the 8. So the teacher is helping everybody. We're distributing through to everything. Now, if you have something like, and you don't have to write this down, I'll even write at the top here, I don't know, 27 parentheses 16. That says 27 times 16. Those parentheses represent multiplication. We're going to look at it the exact same way right now. So we've got this example here, 3 parentheses 4 plus 8. What that says is we do multiplication. So that multiplication sign is there. And we're going to do 3 times 4. This is shown right here. 3 times 4. And we're going to do 3 times 8. Plus 3 times 8. And the only reason it's plus is because there's a plus right here. So that stays there. And so this looks like a lot of work. Why wouldn't you just do 4 plus 8 and get 12 and do times 3? That seems like it would be a lot of work. We're going to start using variables. And so instead of an 8, it might be an x. Now we're going to try and break things out of parentheses and break it out of that setup. And so let's look at some examples. We'll use the distributive property here too. I think in some of your book assignments, it says use the distributive property or write the product using the distributive property. What we're looking at is still some of that mental math. And I've alluded to this a couple times in class too, that rather than doing 9 times 52 like this, I look at it as 50 and 2. Do 9 times 50 and 9 times 2. And that's really what this distributive property is we're saying, well, let's take 52 and let's break it up into smaller pieces, because that's easier to do in your head. So now we're going to do 9 times 50. 9 times 50 is going to be 450. 9 times 2 is 18. And 450 plus 18 is 468. So rather than writing out 52 times 9 and doing it this way, which you can still do, but it's longer, we're looking at how can you do that in your head? How can you break 52 apart into smaller pieces and do it in your head? And this distributive property is how we would do it. So 8 times 33. Well, 33 is just 30 and 3. That's easier to do in my head. 8 times 30 is going to be 240. And 8 times 3 is 24. So together I get 264. And you can do those problems easier in your head. It's not necessarily easy, but easier in your head than setting it up kind of the traditional way and doing 8 times 3 and carrying the 2 and adding it back on and all that other junk. This is easier to do in your head. And that's what this distributive property, that's another way we can use this distributive property. Okay. I want to make sure that I don't spend any more time than I need to. I'm already at 10 minutes. I'm going to hurry up. Okay. I'm going to have you fill in a couple of vocabulary pieces. So things that are alike. We're going to look at combining like terms. We're almost done. Things that are alike are ones that both have an x. 4x and 3x are alike. It's like 4 apples and 3 apples. A constant has no variable. It's always 2. It doesn't matter what x is. 2 is 2. If x is 5, 4 times x would be 20, and 3 times x would be 15. If x was 3, 4 times 3 would be 12, and 3 times 3 would be 9. But either way, 2 is 2. So that's constant. When we talk about coefficients, coefficients are the number before the variable. That's just what they're called. So pause it if I'm moving too fast. Last ones I'm going to do. Maybe try a couple on your own. So we're going to simplify. We're going to combine the things that are alike, combine like terms. We're just going to make it simpler. So 72 p's, 72 p's minus 25 p's. If they're both p's, think about maybe peas on a plate. So you're eating peas. You got 72 peas, and you need to eat 25 peas. How many peas are you going to have left? Since they have the same variable, we're going to combine those together. We're going to subtract, and we're going to get what? 47. Double check my mental math here, because I don't want to get it wrong. Yes, 47. Good. Whew. So I'd have 47 p's left over. I combined those like terms together. Look at the next one. I've got 3/4 x to the 4th plus x to the 4th. They're like terms, x to the 4th and x to the 4th. So I have to combine these together. I can add them together. Well, 3/4 plus, how many are there here? Well, I can see them. There's 1. If there is no coefficient, it's like having a 1 there. There's 1 x to the 4th. I can see it. It's right there. All right, so now what's 3/4 plus 1? 1 and 3/4. X to the 4th. So combining like terms is just saying if the variables are alike, add those coefficients together or subtract those coefficients. Combine them. Try these 3 on your own. I'm assuming you paused it. I'm assuming you tried it on your own. If you didn't, do that now. Pause it and try it on your own. If I look at 3a, the variables are the same. So we're going to combine them together. 16 p's plus 84 p's, 100 p's. That's a lot of p's on your plate. For 3b, t and t squared are different. They're not alike. We're stuck. We can't do anything with those. That's apples and bananas. Can't do it. So negative 20t minus 8.5 t squared. That's it. That's our answer. We can't combine that any further. That's as simple as it gets. And the last one here, m squared and m to the 3rd power. Again, not alike. We can't combine them together. The simplest we can make it is like that. Okay, that's it. That's the end of the video.